This is Geometry, Unit 3, Day 5. We're talking about proofs about lines and angles. This is day number 2. And what we're going to talk about here is about a linear pair. A linear pair of angles are supplementary and they're adjacent. If two angles are a linear pair, then they are supplementary. So if we have a straight angle and we break that into two pieces, we could label those angles with some letters out on the rays and label the vertex. So we know that angle AXB, angle BXC are a linear pair because they're supplementary, they make up a straight line, and they're adjacent. They have a vertex they have a common vertex on a common side. Now for vertical angles, these are two opposite angles. They're two angles opposite one another at the intersection of two lines. So if you have two lines going in opposite, not with the same slope, of course, and if we number those angles, use any numbers that you wish in any order that you desire, but what I would like to point out is here you would have a linear pair. 1 and 2 would make 180. 2 and 3 could make 180. 3 and 4 could make 180. 1 and 4 could make 180. Those are linear pairs when they're next to each other. But if they're two angles opposite one another, those are open in opposite directions. They have the same vertex, but they open in opposite directions. So angle 1, angle 3, and angle 2, angle 4 are vertical angles. If two angles are vertical, then they are congruent. This angle here is going to be congruent to this one, and these two will be congruent to those. Think about it like this. If this is 150 degrees, what would the measurement of angle 2 be? That would be 30 degrees. If angle 2 is 30 degrees, what's the measurement of angle 3? Remember, these are a linear pair. They have to be 150. Notice that opposite angles, what we call vertical angles, are the same measurement. What would 3 and 4? What would that make 4? Or 1 and 4, what would that make 4? Notice again that opposite angles, which in this case would be, these are vertical angles, they're going to be the same measurement. They're called vertical. Okay, now we need to identify, do we have vertical angles, a linear pair, or neither? 1 and 2. 1 and 2 are making that half a circle. So they are a linear pair. 1 and 3 are opening in opposite directions. One's opening up, the other's opening down. So they're vertical angles. 1 and 4. What type of angles do you think those are? That's a linear pair. Those two angles put together are making this straight line. 4 and 5. 4 and 5 don't have the same vertex. They're not next to each other. Both vertical and linear pair need to have the same vertex. So these come out to be neither. 4 and 2. Those are vertical angles. 5 and 8. 5 and 8 have different vertices, so it's neither. What do you think about 5 and 7? Again, they also have different vertices. Both of these types of angles, linear pair and vertical angles, they need to have the same vertex. What about 5 and 6? Notice that together, if you shade in 5 and you shade in 6, you have half of a circle. So that's a linear pair. Here we're looking at the measurement of angle 4, and we know it's 63 degrees. How are we going to find the measurement of angle 1, angle 2, and angle 3? The measurement of angle 2 is also going to be 63 degrees because it's vertical with angle 4. Vertical angles are congruent. And then the way we figure out angle 1, the measurement of angle 1 plus the measurement of angle 4, those are supplementary, so they add up to 180. We know the measurement of angle 4 is 63. So we're going to know that this is 117 degrees. And then angle 3 would be vertical to angle 1. So it's also going to be 117. What if the measure of angle 3 was 121? What would we know? The measurement of angle 1 was 121. And the measurement of angle 2 plus the measurement of angle 3 would have to be supplementary because they're a linear pair. So the measurement of angle 2 in this case would have to be 59, making its vertical angle also 59. On the next page, we're looking to write and solve an equation to find the value of x. For example, 3a, we need to look at what information they give us and what relationship we can recognize that would be true about those two angles. Notice that this figure is made up of two lines that are intersecting, the angles that are labeled are on the same side. They're making up this straight line. 113 is this angle. 4x plus 1 is that angle, and they're making half a circle. So I know that 4x minus 1 and 113 add up to equal 180. Bring our two numbers together, so 4x plus 112 equals 180. Subtract through and we'll get 68. When we divide by 4, we'll get 17. The question is, solve for the value of x. X would be 17. Let's look at letter B. What relationship do these angles have with each other? When you look at this angle, and you look at this angle over here, notice they're making more like a bow tie rather than a half of a circle. They're not next to each other. So these are called vertical angles. 4x minus 8, 18, is going to equal 3x plus 4. If two angles are vertical, then they are congruent. So we'll subtract the 3x, add the 18, and that's going to give us x equals 22. Now that's not 22 degrees, that's just is 22. If we needed to find out the angles, we would plug 22 in to our equation. But the directions ask us to solve for x. Example number 4. Find the value of x and y. Which angle should we work with first? Well, if you notice, this angle has a y, this angle has an x. We don't want to work with two different variables. We want to work with variables that are the same. So what we know about the 16 and the 9x plus 5 is that they're side by side. They make up this straight line. They are a linear pair. So they add up to 180 degrees. And when you divide by 25, x is 7. So if x is 7, we still need to figure out the value of y. Well, y is over here, it's 4x. I'm sorry, 4y. So I know that 4y and 16x make 180, or I can talk about 4y and 9x plus 5 are equal to each other. Your choice. You can do either one. I'll talk about how 4y is equal to 4x, x is 7, plus 5. So y is going to be 17. What relationship, which angle should we look at here? Should we look at the ones next to each other? Should we look at the ones across from each other? You have to get good at recognizing which set to work with. Notice that next to each other, one has an x, one has a y. One has a y, one has an x. One has an x, one has a y. Opposite angles have the same type. Opposite angles, because the two lines are crossing, it's kind of like the bow tie. These are vertical angles. So I know that the 9x plus 2 is going to equal the 10x minus 7. I'll bring my 9x over. So we're going to add 7 across. I think I was getting ahead of myself there. So x is going to be 9. If x is 9, how are we going to calculate what y is? You could plug the 9 back in. 9 times 9 is 81 plus 2 is 83. So this should be 83 degrees. We could do that. Or you could even make these equal to each other because they're vertical angles. They have the same variable. We can work with that. And then we divide by 9. So y would have to be 4. Okay, the last one we'll talk about today is our right angle congruence theorem. Remember, a theorem is a statement that we can prove. So we're going to do a proof to show where this theorem can exist. Theorems make future proofs easier. So theorems are a good thing. You want to get more theorems because that gives you more shortcuts. If this theorem takes 4 steps, then you're going to save multiple steps on any proof that requires the use of this. So you don't have to reprove it every time. You just get to use this theorem. This theorem is a shortcut. Okay, what do we think about if two angles are right angles? What do you know about right angles? If two angles are right angles, then they are congruent. They would both be 90, that's true, because right angles are 90. But in our theorems, we won't talk about things being equal, we won't talk about things being a certain number. We typically talk about them being congruent. Sometimes we consider them to be supplementary. We don't consider them to be numbers. We don't consider them to be equal. So we need to prove that they are congruent. So using our picture here, we see that angle K has a box, so that makes it a right angle. Angle L is a box, so it makes it a right angle. K and L are both right angles. angle K is a right angle. Angle L is a right angle. That's from our given information. So we write the word given under the reasons. Now, all this says is it's right. Now we're going to say that the measure of K is 90. Where does that come from? How do we know that the measure of K is 90? If right angles, then 90 degrees. Right angles mean that their measure is 90. So this is the if-then statement that helps us switch from 90 into a number. Notice that we have both pieces here, K and L, that are both equal to the same thing. So it's kind of like A equals B and B equals C, so A equals C. And that's a transitive property of equality. Then we're going to turn the equalness into congruence. That's the only part that's different. K is on the left, L is on the right. If equal, then congruent. If two angles are equal in measure, then they are congruent to each other. That would be the long amount of words you could use. This is the shortcut. Enjoy.